All right. Morning, everybody. Sorry I posted that stream link pretty late. Just waiting till 8 o'clock here. We're just hanging out. There's another Spider-Man that actually does have 8 arms? What the? Six arms with his legs, it's 8. That's good. It's feral? What the heck is on? Owen, what are you talking about? Oh, that's great. Benny, I didn't play volleyball in high school, no. But I played like intramurals to university. My high school was huge. It was really hard to be on a team unless you played rep in that sport. Basically impossible, but yeah, it was 2,500 kids. So I played hockey in grade 9, and then they found out I didn't play rep. So then probably just wasn't good enough anyways, but I didn't get back on the team in grade 10. And then I played rugby all 4 years because that was more of like a no one played rugby kind of thing. So there was no rep rugby. So that was fun, but yeah, it was pretty well the only sport I played consistently. Yeah, Ben, but it's like intramurals, so like anyone can play. It's just like you just sign up and then you get placed on a team. But it's still really fun. So like once you guys are graduated high school, like anyone can play these intramural sports, but it's like super competitive and weird for some reason. There's still like refs and stuff. So I remember being sad at like my last rugby game, thinking that was like the last like, you know, high school game that I would have like a referee for, or like the last game I'd ever play ever with a referee. There's some men's leagues in hockey that have referees, but very few, right? So anyways, it was just like, oh, bummer. But then turns out university intramurals had tons of refs anyways, and it was fun. Alrighty. Just gonna check here. I thought I did all this stuff yesterday, but I'm clearly getting old. Like I didn't post a YouTube link till like 5 minutes ago. And then I thought I sent you guys a lesson, but I didn't do that till like right now. So I don't know what's going on. I thought I did all this last night, but clearly I'm going a little crazy. All right, so we are about 8 o'clock. Yeah, perfect. All right, I'm going to take out the attendance here, and we'll, come on. Rock and roll. Okay, where's the attendance button? Yeah, make chat time to 8:10. What? What does that mean? You want me to not? Okay. Ben is here. Did I see Jared say anything yet? Because you sent the stream late. Okay. Sorry, Jared. Yeah, not yet here. Okay, perfect. Sam, did Teddy show up? Thanks, Jared. Yuli, I saw. Kathleen, I saw. Katrin, I saw. Oh, there's Teddy. Did I see Crystal? I'm not sure if I saw Crystal. Normally, like, early on. No, then I did not. Maddie, no. Crystal, no. SJ? I think he's like flying maybe sometime soon. Yeah, I would say he's not here then. Who is Moo Wrong? Sade's here. I don't think I saw Zion either. Sorry, I just... Whoa. What's my favorite color? I don't know. I actually think purple. I really like purple. I don't know. It's kind of weird, but I like it. Ruth, Owen. Owen I saw a million times. Yeah, Benny I saw. Larissa popped in. What's your favorite color, Ben? Lucas is here. SJ's here. Erica, I'm pretty sure. Yep. Maroon. And Kendra I saw as well. Awesome. Okay, so missing, and I might be wrong, I might have missed somebody. Zion, Maddie, and Crystal. Okay. Oh, and that guy is whack. It's the weirdest looking Spider-Man. Oh, man. Okay, I'm going to send off that attendance. Yesterday, we did distance time. Oh, there's... Perfect. Zion is here. Thank you, Zion. All right. Perfect. Yeah, thank you. Actually, that wasn't so bad, Zion. It takes me about 4 minutes to do the attendance anyways, but I think I used to, like... you guys aren't as bad as my grade 11 class, but my grade 11 class, they roll in like so late, which doesn't make any sense at all because they're like all period 2. So I was going back and marking them late after marking them absent. And like it was always like interrupting the lesson. It was ridiculous. So I started telling them they had to go tell Mrs. Banna. So if you guys are super late, we would just make sure you message Mrs. Banta because I don't really know, unless we're like doing nothing, which we typically are trying to start taking up homework. There's a lot going on for me, so it'd be nice if you guys would help me out. If you're over late, Zion's good. I got you. I was still finishing up, but yeah, I don't understand it, Sam. It's the weirdest thing. All right. Anyways, holy, there's 6 school talk notifications. I don't think Cameron's ever late, Sam. I think Cameron's always on time. It's always the rest of those little games. Okay, so we're going to take up some of that homework because I think some of that was maybe a little hard. I'm not sure how you guys did on that. For 6.5, I asked you to do numbers 1, 2, and 4 on page 368. So is there any questions about any of those? 368, number 1, 2, and 4. I can show you some of those, what I meant by that. Whoa. My computer's spazzing out. Not that screen. Let's go to this screen. Okay. So number 1 was when you're supposed to like match these suckers up, right? And some of them are a bit weird, but you're trying to just in general think things through, right? This one, somebody's walking at a steady pace. He waits for a stoplight and then continues at a faster pace. After being at school, he returns home without stopping or slowing down. So if I was to look at that, right? He's walking to school, stops, and it says he walks at a faster pace, so it makes sense that this is a little bit steeper in here. Right, I'll zoom in for you. This is a bit steeper. Then he's at school for a bit, and then he just, I think it says he runs or he comes home at a steady pace, right? He heads all the way back. Crystal, if you could tell Mrs. Banta you're here, that would be great. And then if we're looking at B, right? It's a log floating in a river. It goes through 2 sets of rapids. Rapids make things go faster, right? Before going over a waterfall, so it would make it go really fast and into a lake. So probably this one makes the most sense. Something's floating along in a river. You know, it's going through some rapids and picking up speed, right? Going through a rapid, picking up speed, rapid, picking up speed. Goes over a waterfall, crazy fast. And then it just like the distance, if we're thinking about distance and time, the time stays like keeps going, but the distance, it stops, right? Because it's hit the lake. It just sits in the lake. So it's going along in the river, hits 2 rapids, waterfall, then a lake. So that one kind of makes sense there. This C is kind of stupid because it switches up from distance time, right? It talks about the like fare to get in a cab. So it's changing every 100 meters kind of thing. So this is like this one here. I don't know. It's kind of a silly question, but you know, you're starting with, instead of like distance and time, looks like we've got the cost to get like the cab plus the distance traveled. And so the cost depends on the distance, right? So you'd have actually, instead of time and distance like this one, you're actually going to have your distance on your x-axis and your cost up here on the y. So it costs like this much. That's like the minimum fare. I don't know if you guys ever took a taxi before, even if you just take like an Uber or something, there's like a minimum charge. And then what it's saying is every time you travel 100 meters, so as soon as you start, boom, here's your new cost. It's like, okay, you hit that 100 meters, boom, here's your new cost. Next 100 meters, boom. So it's jumping up like that. So that's where that one comes from. And you just kind of assume this last one is this last one. But a skydiver, he enters a plane. He jumps out and free falls until the parachute opens kind of thing. So I don't really understand this part because it never really talks about a first part. It just says he enters the plane. Maybe this is him like walking up the ramp to get, I don't know, climbing up the plane. I don't know. And then he gets in the plane and goes up, up, up. And then he goes a bit and it's non-linear because he's like picking up speed. And then he hits his parachute, which supposedly makes him travel the same speed. Anyways. I guess that makes sense, eh? Takeoff. On the runway or whatever. Yeah, that makes sense. Yeah, I don't know. Maybe not as fast as it climbed. Just, it's probably not thinking about horizontal distance, right? It's thinking about vertical distance here. It wouldn't care so much about horizontal, right? It's not, this isn't like the shape of the plane. This is like the height off the ground, and this is time, so it's different. So in terms of, yeah, it's going really fast, right? Maybe as it's on the ground, but anyways, it wouldn't be getting that much height. Okay. So then we had 2 and 4, and I don't need to describe both of them. Somebody asked a question about 4. We can definitely go through 4 together, but does anyone need to see 2? I don't see too many comments. If you do need to see 2, there was my little answer key as I was working through it, so you can just pause it here. But let's look at 4. So number 4, drag racer begins. So it's like, you know, when they do like the, I don't know, I think there's some stupid game on your phone for that crap, about shifting gears and stuff. But basically, linear or non-linear relationship. Well, the reason that I know it's non-linear is if you took a ruler right now, right, and we were to line up the slope here and here, that's much different than the slope between these points and definitely between these points, right? Whereas remember, for it to be a linear relationship, I should be able to line up mostly like all my points pretty well on the thing, but you can see that it is changing every time. Between every single point, the slope is changing. So it's nonlinear. So part B says, verify your answer, be creating a table of values. So remember, this is actually something we did back in chapter 3, your chapter 3 task, where you'd make up your X and Y. And remember, basically, if you look at all of these points along here, these are your X values in here, right? Basically, you're going to have X's 0, 1, 2, anyways, all those ones along there. So you're going to line it up with an X values from 0 to 7. You can see that I did that right here, right? So these are all of your X values. It goes up to 8, but there's no point at 8, right? So we just got to go to 7 here. And then your Y values, they go from 0 to 500. So I would just list them, right? So the point 0, its Y value is 0. So I look over here and go bingo. Then I see the point 1, and I said it was a quarter of the way up. I don't know. It's hard to be accurate on a graph with this scale, right? That's why we hopefully would have done this again with a larger scale. Maybe you go up by 25s instead and extend this graph, right? That would have been a better one. But anyways, I said it was about 25. Then I said this is about halfway up, so 50 for 2, right? 250. 3 looks to be bang on at 100. 4, I would say, would be halfway again, so 150, and then so on. So you get all your points here, and that's your table of values. But remember what you do to find out your differences, right? The differences were all about the slope. So remember we talked about, this is way back in chapter 3, but if you subtract 25 minus 0 and get 25, 50 minus 25, you get 25. You go, oh, sweet. Like, if all of these are the same, it's linear. But then you start to do 100 minus 50 is 50, okay. And then as you do your subtraction, they're all changing. So because there's a change in your Y values, then you don't have a linear relationship. It needs to have a constant change in Y. And this actually tells us a lot, right? These are meters here, right? And these are seconds. And so what that means is between 0 and 1 seconds, right, it went up 25 meters, or it traveled 25 meters, I guess. I'm still thinking of the plane example, but its distance was 25 meters. So it went 25 meters in that 1 second. But then it changed, right? Yeah, it went 25 meters in this 1 second, but down like here, between second 2 and 3, it went 50 meters, right? So it goes 50 meters per second, or 50 meters in a second. And then you can see it gets even faster and faster as we go. We saw it had 125 meters between second 6 and 7, right? So it's going from 25 meters per second at the start all the way to the end where it's 125 meters per second. So a lot faster. So that change means it's not linear. Okay, so that's for part B. Part C says, describe the motion of the drag racer as it moves down the drag to the finish line. So basically, I would say it's continually getting faster. You could use the word accelerating like we talked about yesterday, right? It's getting faster and faster. D says, once the drag racer crosses the finish line, a parachute opens to slow it down. Draw the graph to show what this might look like as the drag racer slows to a stop. Okay, so if I was to finish this out, right? Let's pretend, this is where the finish line was. I don't think it really tells us where the finish line was. It doesn't say. Let's just pretend that 7 is. Either way, what you do is you want to make this thing come to a stop. And we know stop is flat line. Just like out here, like if you were extending this curve a little bit, right? This bit would come all the way out and basically come to a flat line, which would be stop, right? The distance isn't going up or down. And so eventually we want to kind of have this thing go to where it will be a flat line. So we want it to be stopped. Yeah, 500 mark, probably Zion. That makes sense. Yeah, maybe A, why not? 500 meters. So what you need to do is it just won't go like this, right? It doesn't just go like super, super, super fast, like it's going up. And what did we say? How many meters per second was this? I don't know, 125 meters per second, right? So it's not going to do that. And then just instantly with the parachute, just like, imagine you'd like break your spine. So what it's going to do is it's going to go from that speed and it's going to slow down. Maybe it slows down quickly, but it's going to like take the slope and it would be more of a smooth curve to get to that stop sign. Stopped. I was going to say stop sign, but stopped slope, right? Horizontal slope. So it would come up. And yeah, if I can maybe make that to be like Zion said at 500 meters or whatever, I'd do something like that, right? So the slope is smooth in here. The parachute hits, and then the slope is slowly becoming more flat. It wouldn't just go like boom, boom, quickly. Zion, you're getting all specific with us. So something smooth. It doesn't have to be the exact same. Like, you could have just like, extended this a little more, like as long as it flattens out. There's no real specifics about the distance on this thing. Either way, just make it flatten out. That would be a pretty long parachute. That parachute would take like as long as the whole race did, but whatever. Okay, so that was number 4. Maybe it's a weird dragster. Yeah, you never know. All right. Cool. So hopefully you guys are semi-comfortable with the distance time graph stuff. Again, sorry for sending you that note yesterday, the completed one. Hopefully I didn't do that again today. What was fast, Benjamin? All right. Part of this unit is all about like data, right? And predicting trends and things like that. Oh, taking up the homework. Yeah, true that. I'd already done it. I actually was thinking today, like, I was like, I'm going to see if I can like pre-record the lesson. And so like, literally, I kid you not, you guys would laugh at me if you saw me do it, but I was sitting here and I like went up, did all the homework. I started the lesson. I was like going to pre-record it. That way I could help people one-on-one because I thought yesterday's lesson was a bit of a gong show and people might have been confused. And so I was like talking to the camera the whole time I was doing stuff. But on my app that I use, there's a button for like start streaming, which is what I'm doing with you guys right now. But it's not like recording it to my computer. It's just YouTube records it for me, right? So I never have to hit start recording. But basically, I hit streaming instead of recording. So I was talking to the camera the whole time, doing all the homework. I started half this note. and I didn't record any of it. So I was like, oh, you goof. So anyways, it's not gonna work. Yeah, I didn't. Yeah, you're right. Oh, and I didn't press record. So I was like, I felt like so stupid, right? What a waste of time. Yeah, big oof indeed. Okay, so why are we talking about hypothesis, sources, sampling, all these different sorts of things? Well, basically, this unit, right, allows you to graph things, make a scale that works for your data, come up with it, like to be able to talk about how strong of a correlation it is, right? If these two things are related. Or remember we talked about how sometimes you can choose things that don't relate, like the month people are born in and their like height, right? So not a whole lot. You call me a boomer because I didn't hit. I'm streaming on YouTube right now. Boom me, son. Anyways, I am kind of a boomer. Yeah, a little bit. Whatever. Whoa there. So the goal for the unit would be that you know how to come up with your own data. And how do I kind of like think about two things? And how do I come up with two things that I might be able to graph that will have a relation? And by relation, I mean like they're going to have some sort of correlation, right? Like as one gets bigger, the other one gets bigger. Or as one gets bigger, the other one gets smaller kind of thing. So some sort of pattern. Okay, sorry, 1 second. Yeah, it just stares into the distance, questioning my life. All right. Let's rock and roll. Sorry. Hi, Benjamin. All right, full screen. Do you guys have this yet, by the way? Can I even go 1080p? I thought I like maxed out at 720. Yeah, the school's computer actually hates me that I use the dual monitors. Okay, people got it. Love it. The problem with this computer, I love this computer, and it's currently the best computer in my house. That's the downfall, because I used to have this great iMac, but it's just like sat for so long. I bought the thing, and I bought it like used, and I had to put in like a new screen into it. So I was super proud of myself for that. That was like something I did like right at university. The end of university, I was like, oh, this is gonna be so great. I had such a good deal on it. And then I went away for China for 3 years, and then it just like got Appleified, and the updates came, and the thing is like the world's slowest computer. So anyways, I didn't even own it for that long, and it's completely useless. All right, so when you guys are going to come up with something, because this is going to be something we do, you're actually going to have a little project. That's how we're going to end this unit, is you're going to have to come up with a hypothesis. And basically that hypothesis is like you predicting something to be true. And I know you guys have done that in science before, but it's like if I'm just sitting here right now and we're back in class again, I might say like, okay, like I'm pretty sure, I don't know this for certain, but like the older you are, the taller you are. And then we all, measured our ages and then our heights. And maybe it didn't work, maybe it did, but we're predicting something, right? Or maybe I think like, okay, like, the closer to Toronto you live, the more body odor you produce. I don't know, that's probably really bad. I have no idea. I'm just like throwing off things, but making predictions and stuff like that, right? I don't know what the penguin is doing, Kathleen. So when you're first starting out, you need to make that hypothesis, and that's kind of like your prediction, right? So we need to make that hypothesis. Kathleen's possibly offended by my I don't know why body odor. I was trying to think of something. I was like, what is something that I could say other than height? I'm sorry. It probably sounds mean. Benny's like, I live in Hamilton, man. I'm pretty sure. Wait, Kathleen, you live pretty close, don't you? I don't remember now. I'm sorry. I didn't mean it. I just couldn't think of anything. I couldn't think of anything. I'm sorry. Anyways. So, how do you prove this thing is true or false? Well, basically, you use statistics, right? And your statistics are what's going to show that your idea is true or false. So that requires us to go out and get that data. Oh, Kathleen's like straight up in Toronto. I'm sorry, Kathleen. Don't tell your family, they'll kick my butt. I didn't mean it. Okay, so it's actually probably completely the opposite, to be honest. City folk are very proper. Okay, so example. Let's try something. So let's state a hypothesis and an opposite of each statement below. So so for the driver's age and risk of having an accident, you guys in the chat, tell me something. Those are the two variables. You've got driver's age and how likely they are to have an accident. What would you guys say would be a hypothesis for those two variables? Give me a statement. Doesn't have to be true. Does not have to be true. Just give me a statement for driver's age and risk of having an accident. Oops. This thing was something that I wasn't able to delete before. It doesn't matter. It won't make any sense right now. Well, not getting much input from the crew right now. So this is what I mean. I'll show you one. Basically what you would say, a driver's age and risk of having an accident is, let's try this. The younger you are, okay, well, Lucas wants to go the opposite. So Lucas says, old people crash more. Okay, so the older you are, the more likely you are to have an accident. And Kendra's was completely opposite, right? And so it's totally okay. There's no wrong answer for those. What we'd have to do to prove this, right? Like you can't have well, I guess there is a wrong answer, but you'd need statistics to prove it, right? Teddy, it's because they drive slow, but they still drive slow into things. I think what Lucas is going on is really old, right? So here you go. The older you are, the more likely you are to have an accident. So what I would try to do, right, is I would go and get people's age and I would figure out the number of accidents they have, and that would be my statistics for this. But here would be the opposite statement. What you don't want to do with an opposite statement is negate both of these things. So think the older you are, the more likely you are to have an accident. The opposite statement would not be, think about this. So if I say old people crash more, if I opposite this and I say the younger you are, the less likely you are to have an accident. So I went opposite with older, I went younger. The younger you are, the less likely you are to have an accident. That's a double negative, right? That makes both of those things, opposite. So it actually says the same thing, right? The older you are, that means old people are more likely to have an accident. And so if I do the opposite of old and I do the opposite of more, so the younger you are, the less likely, that's saying, okay, young people don't have as many accidents. That's actually the exact same statement, right? So you don't want to have a double negative. Normally what you would do is you would just negate one of these things, right? Do the opposite of one of them. And so an opposite statement would be the older you are, or you could opposite younger, right? The older you are, the less likely you are to have an accident. And that would be, I'm just going to write in brackets, opposite statement. Does that kind of make sense now? You don't want to have a double negative. Don't want to have a double negative, because that's when you think about double negatives in math, it means positive, right? Okay, so somebody give me a hypothesis for school marks. Lucas gave our first one, so let's have somebody different give our second one here. Sam, that is a very easy way to get your butt kicked, buddy. That's not good. Okay, attendance at school and marks. What would you guys say is your hypothesis? Hypothesis. No, Ben says, no show, no good marks. Okay, let's do a little less caveman, but I love it. So in this case then, the more absences you have, I guess we'll say the less you attend school, the worse your marks are. And obviously there might be some outliers there. There might be some people that like never show up and just get 100s. And then the opposite statement would not be the more you attend school, the better your marks are, right? That's the exact same thing. It's saying the exact same thing, right? So the less you attend school, the worse your marks are. That means don't, like, let's go Ben with it. No show, no good marks. But then if you make both of those, yes show, yes good marks, it's the same thing. It's saying the exact same thing. So you want to just negate one of them, right? So the negation here could be the less you attend school, the better your marks. Imagine that was true. And so opposites are like, when you're done your data, this is like the thing, you know, if this wasn't true, then this other thing would be true. It would be the opposite. Or maybe there's no correlation in both, right? Okay, the height of boys and the height of girls. Those two things aren't related at all. Why does it always have to be height? I don't know, Kathleen. I tried to go body odor and it backfired. People didn't like me. So this one here, it's really hard to come up with something, right? Wouldn't you agree? You wouldn't say like, because they're literally not relatable at all. It's just like one is taller than the other, one is not taller. So you could just have that in there, but we don't really need to get into, maybe they're all the same height. Yeah, you never know. So this one here, this one would be the easiest. You could just say, boys are taller than girls, but it wouldn't be, and then the opposite would be girls are taller than boys. But it wouldn't be something where you'd have this like linear relation. It's just like a yes/no question, right? It's not a trend. It's not a trend. Okay. So, those of you that are in science, primary data is basically any data you collect yourself. Crap. I hate OneNote. I'll just type it. Any data you collect yourself. So, an example of primary data, I'm so happy it got basically banned, but last year, when you guys weren't here, and at the start of this year as well, like back in first semester, do you remember when all those students would go on and be like, please guys answer my survey, please guys answer my survey for this class or for that class, and it just went crazy. Well, that stuff is primary data. That's an online survey because you're making up the questions. People are typing it in and then you're collecting it. Another classic example is just like you literally asking your friends, something like that, right? So basically any sort of survey or online survey, something like that. Or, you know, it could be something like even just straight up observations. So I don't have to make a survey to figure out, like, at my light here, I'm pretty sure, you know, that cars do not stop at my stop sign out here on this neighborhood. This stop sign is brutal. Like, everyone just does a rolling stop. So I'm going to say, like, I'm going to watch the cars and I'm going to make a checklist of, like, you know, maybe I think that, like, trucks stop less than cars, something like that. And so I'll make a little checklist and I'll just make observations, right? So that'd be my own data collection. And that's me doing that. And then secondary data basically is data someone else collected, right? In general, this is a dumbed down way of saying it. Someone else collected. So some issues with that, right, is you don't know how reliable it is. It could be that it was done by, like, a university or a research institute, and it's a million times more accurate than the data that you could have got yourself. It's probably more on a global scale as well, right? Something that you found online. But it also could be a bit sketchy. It might not be exactly true. There might be, you know, some things wrong with the data, or there might be bias. Or it could just be straight up lies. So we're going to talk about bias and stuff in a second. But this could be something like, all right, using the internet. Or it could be even like stuff that you heard as like rumors from your friend or something like that, right? Even I could go through a magazine or book or something like that or whatever. Friends. So if I was to talk about, remember my car example at the stop sign here? If I was like, actually, you know what? Like, I'm just going to have a friend do it. Or like, I'll be like, hey, neighbor, you seen anyone stop there? He goes, yeah, I saw two people stop there yesterday. Well, that's like, you know, hearsay. It's not something that I've recorded. It's not something that I've made a note of. It's not in my own chart. It might not be true. That would be secondary data, exactly. So one's not necessarily better or worse than the other, but it's nice to get primary data as well. Oh, sorry. How tall am I? Hey, Michael. No, Michael, I only switched to Zoom in business because there's people that, you know, were off in China or wherever that couldn't access. But this class and my other class, there's not that problem right now, at least. But yeah, although in business, people are watching it later anyways, but it's just, you know, it's hard to get on there for them. I still like the YouTubes. Okay. Frick, that's tall. Yeah. Anyways, I'm 6'4", not 6'9". Okay. So when you're going to collect your data, there's a couple things. No, my class didn't get. YouTube gets censored. YouTube's blocked in China. You'd have to use a VPN. But I guess supposedly a couple of my students in my class did not have the VPN. So I was like, all right. Get good, bro. Okay, sorry. Whoa, my whole system's all messed up here. Yeah. Dang, son. Dang, son. All right. So basically, if you're thinking about collecting data, there's a couple different like group sizes you need to think about and ways of doing it. So let's talk about that. Basically, the population is the entire group of people or items being studied. So if you think about, you know, if I want to do a study for Great Lakes, the population is every single student at the school, okay? I want to do a survey about the happiness of students, okay? And I want it to be pretty in-depth, right? I want it to be pretty in-depth. Well, it would be really difficult for me to go around and get and expect every single student at Great Lakes to answer my survey about how happy they are. So That's going to be pretty impossible. So what I do instead is I give a sample size, right? A sample is any group or a smaller section of people, from that specific population. So instead of like surveying all 150 people, I choose 20 people, and that sample hopefully represents the entire population. And that's the same way that the government would send out surveys, or research companies would send out surveys. They want to know, does somebody like this brand of coffee? Okay. Well, they're not going to, survey a whole country or the entire world. They choose a smaller sample size, and then they see if they like that. So a survey is something that we call that is given to a sample, some sort of questionnaire. And it's survey is typically a word used for a smaller size, whereas a census is something that is given to a population. So I don't know if you guys have heard of that, like Census in Canada before, but it's a survey that gets sent out. I forget how many years, maybe like every 4 years, but it gets sent out to every household. Now, not every household comes back, but it gets sent out to every household. And it's a questionnaire for them based on things like income and, what type of industries they work in, how many kids they have, things like that. So that gives us a better idea of population, how many people live in our country, stuff like that. Okay, so there's two different types of samples. When you're choosing the people at Great Lakes, all 150 people. I guess that's not that many, right? I just mean it's still 150 people isn't that many. You're right, but it's just a decent number, right? It's a decent number. I don't want to have to go through and ask all 150 people. I'd rather ask like 20. So when I'm choosing my 20, there's two different ways of doing that. You could do it randomly. So I could just we'll talk about 3 different strategies for doing something randomly, but that's like when you give all members an equal chance to be part of that 20. If I just decided that I was going to take students that had marks over 90, right? Well, those people may or may not be more happy than others. Or if I just took all failing students, right? There would be a little bit of bias there, right? Smallest school on the planet. Yes. We're pretty freaking tiny. Hey, the preschool is smaller than us. Give an example of bias. Well, yeah. So if a survey at Great Lakes would be, if I wanted to make the school look good, right? And I want to talk about student happiness, maybe I would only take the students on sports teams. I don't know. Maybe that wouldn't affect anything, right? Or maybe I would only take the students getting above 90, something like that. That would be bias, right? Where I would just randomly choose. I would pick out the things that I think would be well. Majority of this class is not getting asked if they're happy. Are you guys happy? I want you to be happy. I'm sorry. I'll give less homework. What do you want? Owen, you make me laugh. Does that count? Probably not. But anyways, thank you. Thank you for existing. Thank you for gracing us with your presence today, all of you. Okay, so that would be an example. Lol, in that case. That'd be an example of bias. Another example of bias would be just okay, they're trying to no, go take your survey to the 90 over students. It'd be another example would be I want to figure out what people spend their money on. And I only take people, that have $100,000 or more. I just pick really rich people, or I go to a really rich neighborhood. It's what do you spend your free cash on? And they're going to say things like, whatever. I don't know, things that are not necessary, right? But if I went and I talked to a lower income family, that might be more necessity things, right? Things that they need. So, anyways, just an idea of another example of bias, right? Survival of the fittest. Okay, so how do you pick, right? Let's think about this example here. A principal of a school with 1,600 students, lols, not GL, wants to know whether they favor introducing school uniforms. So do they want to get school uniforms? I know you guys love them, but let's ask this school of 1,600 students whether they want them or not. Describe the 3 methods he could use to make a random sample of 200 students, which is still bigger than our school of 150. Actually, I think we're a little less than 150 this year even. So, simple random sampling. Okay, so what is that? There's 3 different ways to get something randomly, to do something fair. It's not fair to just pick... what was the second blank? There's a second blank. It's the census one, maybe you mean? Get a choice. Yeah, they probably wouldn't get a choice. Erica, to answer your question about do we have math on Wednesday, I haven't actually made that decision yet. I want to be able to get through the whole textbook with you guys, so that way you don't have any gaps, because I don't want you to be struggling in grade 10. I just need to kind of think things through a little bit here. We only have one more lesson before we try this little assignment, so I might actually do math tomorrow, now that I'm just thinking out loud here, and then I'll give you a couple days in my math class to work through that project, ask me questions, something like that. So we might do things a little bit different because there's only one lesson left, but I'll let you know. Okay, you'll know that after school sometime. Okay, you'll know that tonight. I think. No, actually, you know what? This is the last lesson. So I will give you this tomorrow. So actually, we'd be done. I'll have a little video explaining this. But yeah, you won't have class tomorrow. I'll be there helping you through that assignment. I'll have a little video explaining that assignment, but we'll do that instead. And I'll give you guys an update about when that will be due. I have to look at it. I made it last year, so I can't remember exactly what it asks you to do. But yeah, we'll get there. Coolio? Big oof. Wait, what did Sam say? Sample, thanks. Also, I don't have the second page, the one about uniforms. Oh, awkward. Okay, Sam, I'm going to post this. No. In the content library, underneath answers for quizzes. No, I'll put it in rubrics. Okay, sorry about that. Chapter 6. Okay, sorry. Where the heck am I? Okay, these ones. So something where you have a simple random sampling. So if I wanted to pick those 200 out of the 1,600, or if we even dumbed it down, like it could be dumbed it down to Great Lakes. It could be those 150 students at Great Lakes and I want to choose 20, whatever it is. It doesn't really matter. But the general idea is simple random is like if I had a list of names, list of every student at the school, And then those students would have like a number attached to them, right? Number attached to them. And you used a random number generator. I should have just typed this. Okay? Or this is like the other way. Basically, the idea of simple random sampling is like pulling names out of a hat. That's the dumbed down version. It's like if you had every student in the school, 1,600 of them in a hat, and you pulled out the names, like 200 of them, 200 of those names, totally randomly. That is simple random sampling. It's as simple as it gets. It's completely random. Realistically, if you had a population that size, 1,600, that's impossible. So instead of pulling names out of a hat, you'd have every student in the school on a list. Our school has that, right? We have the 150 of you with like a number beside you in alphabetical order, whatever it would be. And we could just hit the random number generator 20 times or whatever times we wanted, and we'd have that super simple random list. It wouldn't be just the kids on sports teams or the kids that, you know, we liked or the kids that were above 90s. It would be totally random. It'd be totally random. Okay, so simple, kind of pulling names out of a hat. That's one way of doing it. Systematic random sampling is if you take, let's type it this time, take the same list of students and choose. So if there's 1,600 students and we need 200 of them, right? Well, 1,600 divided by 200 would give us like 8, right? 1,600 divided by 200 would give us 8. So choose like every 8th student. And I didn't have to do that math. You could just pick like every second student, something like that, whatever it would be. But this is also a very random way of doing things. You're just doing like every 8th thing. Ben, I don't know what your number is, and also it's a weird question. What's my number? If the population was higher, Benny, you'd want to pick more than 20 students to make sure that different minority groups are represented. At our school, picking 20, you'd hopefully get, you know, one from each grade randomly, hopefully, right? But it's not guaranteed. Maybe you'd get a couple international students, a couple dorm students, a couple day students, right? Things like that. But you never know. It's not exact. Okay, so then basically, right, your systematic is you choose every 8th student. So you take like, you know, number 8, number 16, number, you know, 24, 32, and 40 as you go. So that would be another way of doing it. It'd be super random, but then you'd have like a spread, right? It'd be a spread. And stratified is when we break up population, so the whole population of the school, into groups based on, maybe I want them to be based on gender. Sorry, based on gender or grade or nationality, etc., whatever it would be, okay? And then choose, well, how many, if we broke up our school, right? For example, if we took, you know, if we're going to break that 1,600 school up into grades, so 1,600 divided by 4 grades, right, would be equal to 400 students per grade. And then what we need to do is we would choose, right, in this case, from those 400 students, we need to choose 50 of them, because 200 divided by 4 would be 50. So choose 50 per grade to make the 200. Oopsies. To make the 200. This part actually doesn't matter for the math, right? It doesn't matter how many students per grade. There might be more in grade 9, more in grade 10, whatever. Actually, maybe I would delete that part, because that it's not exactly useful math, was it? There's maybe not that many. We just need to make sure that we get an even amount from every grade. That way, like, you know, if we did this systematic or simple, maybe we accidentally pick all grade 12s. So grade 9s aren't represented, right? You guys don't have anybody in the survey to, like, you know, be able to voice your opinion on whether uniforms are good or bad or whatever. But if we did this stratified, we'd choose 50 randomly from each grade, and then we'd be able to figure out a better case there. So simple, names out of a hat. Systematic is more like a numerical order, right? Picking like every 8th person. And stratified is more like, okay, you break the population up into groups, and then they choose from that list. And it depends, right? If I wanted to know and I wanted to be systematic about their gender or their grade, right? Gender or their grade. Well, that would be, you know, a different thing as well. Grade would have 4 groups, gender would have 2 groups. So instead of 50 per grade, you'd have 100 per gender, that sort of thing. Okay. The personnel department sends questionnaires. So these are just totally random examples. Sends questionnaires to 75 random employees selected from a list of everyone working at the company. So what do you guys think? They just send 75 random employees. They're trying to figure out, you know, whether people are happy or not. Is that simple, systematic, or stratified? Pause for a sec. What are you umming, Sam? Yeah, good job. Though they're all random, Benny. They're all random, right? So would it be simple random, systematic random, or stratified random? Sorry, I'm just reading Sam's question. So for stratified, you said choose a sample from each group. Yeah, stratified is like, I break it up into the specific groups, and then I can choose to either do like every 8th or the simple after that. But generally, you call the idea of breaking it up to make sure you get a certain amount from each gender or grade or nationality stratified first. And then you choose randomly, or you pick every 8th or whatever it would be. But as long as there is, you know, group breaking involved, it would be stratified. Yeah, I think that answers your question, Sam. I'm not sure if that was your question or not. Yeah, so in this case here, there's a random list. So this one here would be simple, right? Awesome, simple, random. Good job. Okay, so a computer randomly chooses one name from an alphabetical list of store customers, and then also selects every 25th person after that name. So they basically, it's just like, here's all the customers, maybe they're going to win a prize. It just randomly picks one and it goes, okay, this guy, and then this next person is the 25th person, and then the next person is the 25th, and the next person is the 25th. So is this one going to be systematic, simple, or stratified? Yeah, systematic, right? Because it's doing a number system, right? It's doing a number system. It's every 25. The president of a restaurant chain interviews employees at one specific branch. What do you guys think? One specific branch. Well, if this was systematic, this is a trick question. Sorry, I'm not sure if people are still answering systematic for the second one. Kendra's saying third one. So looking at the third one, that's when I break up something into different groups and then pick, you know, from each of these groups. So what are my groups here for part C? What I'd ask you is C, is it random? Maybe it's not random, right? It would be it would be the third one, right? If we think about stratified, I would have to be like, okay, I need to make sure, like if I'm an owner of a company and I want to choose like one employee from every branch, right? That would be my stratified, right? Because I would have different groups, all the different branches. But I didn't choose, one employee from every branch. I just said, okay, all my groups, I just have one group. It's like I just decided to measure grade 9, right? Or it's like I just decided to measure the people in grade 11 or 12. This is not random because he has chosen the branch, right? He said, okay, and maybe it's like the restaurant owner, it's like McDonald's. He looks for the best, nicest McDonald's there is. One where it's not so crazy. There's not that many customers. Everyone's really happy. He knows everything's going really well. And so it's pretty biased, right? He's just interviewing employees at one branch. The simple would be if he took all of his employees, the restaurant owner, right? And he would be like, okay, I'm just going to randomly pick out of every single one of my employees in the country at all the different McDonald's. Systematic would be, I'm just going to have a list of my employees and I'm just going to do like every 25th employee, something like that. And stratified maybe is like, okay, I'm going to make sure I've got, one from each branch, something like that, one from each McDonald's. But here, if he's just interviewing employees at one branch, that's pretty biased, right? Maybe you disagree with me, but I think it's pretty obvious here that he could have chose a restaurant where it's going to be better than other ones. So it's going to be biased and not random. So part D says, the student council of a school randomly selects a number of students from each class. This number is proportional to the size of the class. Proportional means similar, or at least like, 1 to 4, and then that ratio gets bigger and bigger, that sort of thing. 2 to 8, whatever. So let me read this one again. Sorry. The student council of a school, so think about our student council at our school, randomly selects a number of students from each class. Oh, okay. Anyways, don't worry about the numbers proportional to the size of the class. But basically, they're randomly picking students from every class, making sure that they get a couple at least. What it means is like if you have a class size of like 4 and you chose one person and the next class had a class size of 8, they'd choose 2. It's just, that's what proportional means. It's like if there's a bigger class, you don't want to just have like one person representing the bigger class, that kind of thing. Yeah, Larissa's right here, right? It's stratified because we're choosing classes. Stratified because we are choosing to select people from a different class. Okay. Okay, so that's basically it for today. Like I said, tomorrow what I'm going to have you guys do is you're going to have to like come up with some sort of survey strategy, something like that. You're going to have to come up with a hypothesis for something. It could be even something at your house like my crazy thing where I watched cars go by or something like that. Whatever it would be, we're going to talk about that a little bit. Kendra, there is a little bit of work here because there's 15 minutes. If you actually go to 6.6, right here, and you were to scroll up, there's a couple quick questions that are going to be useful. So right here, right, all the ones that I've highlighted in, big oof, in these, it's just some quick little practice. So basically, state the opposite of these. These ones are state hypotheses between each. This one, identify each source as primary or secondary, right? So whether you collected it, the person collected it themselves, or if they got it from somewhere else. And then this last one is, how do you test your hypotheses? Make 2 hypotheses based on the data here. I thought there was one where you guys had to talk about, yeah. So population here, right? Identify what's the big general population. This one here is talking about identify the type of sample, whether it's systematic, stratified, or simple. Sorry, I was like, what's the third one? I was trying to think of something more complicated. So you should be able to just look through those. Those ones are very just like plain Jane wordy. I believe, no, I don't know why I had to scan all of these pages. That seems like an over-the-top thing. So we'll take these suckers up tomorrow at the start. So actually we will meet, and I'll ask you guys if you have any questions about the homework, but if not, you're just free to go and work on that assignment, but I'll explain the assignment. So we will meet in class tomorrow. I'll do a short little video explaining the assignment, explaining any of these homework questions that you got stuck on, and then we'll give you some time to work. Cool. So I'll post in our EDSB page about that. All right, guys. Just some homework tonight. I'll explain a little assignment tomorrow. But other than that, if you get everything, you are good to go and try some of those questions. I gotta grab my Bible for Bible class. All right, I will talk to you guys in a bit.